Okay, welcome everybody to this afternoon's session. Matt Goldberg is going to talk about real-time metacognition. Ruki Zhu and his co-authors are going to talk about benchmark-based vitality of axioms and preconditions for data log theory repair. And Adhar Gupta and his colleagues will talk about learning from single and multi-human intelligence via cognitive and reinforcement learning. So we're going to be learning in real time from single and multiple humans, and I'm hoping the talks will have a lot of vitality. So take it away, Matt.
Thank you. So yes, I'll be presenting our work on real-time metacognition and applications. So to begin with, by introducing the need for real-time metacognition, agents naturally need to be able to reason about and revise their own beliefs and inferential tendencies and reasoning unfolding in time. And one possible source of this reasoning and revision would be from errors these agents are making, among other reasons. And of course, lacking such an ability would impose a severe limitation, which arguably is central to many sorts of brittleness in automated systems. For instance, if a system is going to make inevitable errors, how can they correct these errors if they don't recognize an error is arising, or recognizing that something previously believed was incorrectly believed or not yet known to eventually have been a mistaken belief. And so this ability that's necessary can be facilitated by an in-depth treatment of quotation and quasi-quotation. And in the case of the present work, we've employed the inferential architecture of active logic toward these purposes as well. So then, to begin with an extremely simple example, if we have an agent that is initially recognizing, well, here's Rover, and Rover is a dog. So from prior knowledge of dogs, Rover has 4 legs, most likely. But then, belief 3, at later point in time, the agent sees Rover in person, realizes Rover has only 3 legs, then ultimately our desired course is to recognize that 2 is an error, and referring to the agent making this processing itself directly. So ultimately then the agent could recognize, I'll revise my tendency of assuming that a dog has 4 legs toward the default version, assume a dog has 4 legs unless I have contrary information. And we see that steps 4 and 5 here for the agent's processing are metacognitive, referring to this ongoing process and its past beliefs and what it can have in the future for this revision from a non-default rule into this more default formulation that is based on the lack of contrary evidence. So we've studied this kind of pattern with formal and implemented axioms, and moving beyond this exceedingly simple example, doing this in the context of active logic, and one of the more extended cases is the well-known Fallman hierarchy, dealing with problems such as nested hierarchical categories of mollusks. So the axioms relevant for this are an agent has initial beliefs regarding categories of mollusks and whether they have a shell or not. The mollusk itself has a shell. Cephalopod is a more specific kind of a mollusk, but without a shell, and so on with these narrower categories. Nautilus is a form of a cephalopod, but with the shell, the naked nautilus and nautilus that does not have a shell. And so we want to consider, as a reasoner is acquiring information about some mollusk O, which beliefs it may retain, mark as no longer believed, or overturn, or conceivably, as we saw in the case of the Rover reasoning, updating a non-default rule into a default in a non-monotonic way. Putting this up a little late. So this then includes, as we learn about it, what is going to be exploited as contrary information. So we can see an example of this, such as if an agent initially learns about a mollusk, say Steve, and knowing that Steve has a shell, and then later learns information that later point in time, we see that Steve is actually a nautilus, so we can infer that Steve is a cephalopod, and then of the formulas here, this would imply conclusions ultimately that Steve both does and does not have a shell, and after sufficient processing, a reasonable response for the agent might be, we weaken the non-default that all mollusks have shells into default that's more in line with the evidence that mollusks not in some manner of abnormality or without other criteria will typically have a shell. So then, in this case, two of the issues arising are where are we going to count as contradictory information, but also, even more critically, how would we employ quotation to distinguish the use from the mention of a formula? So in this case, if we're referring to the agent revising its beliefs about mollusks or about dogs and their number of legs, we're not just making use of these in inference, but referring to the fact that we find this prior belief about mollusks and shells to have been mistaken. So both in the simpler case and the example from Fallman, the formula can be used both to draw inferences, but as the subject of direct beliefs as well. And an agent which has well-developed common sense reasoning capability, we expect should be able to handle issues of this sort in a satisfactory manner. So we've examined both of these in the framework of active logic, and this issue does not appear unique to active logic by any means. It's a more general meta-reasoning phenomenon, but we use this as our framework of study in the current work. So then to introduce some qualities of active logic, this is an existing formal inferential architecture, and some key qualities of active logic are the existence of a built-in clock that is tagging inferences with the point in time at which they were derived, and a special inference rule such that now of t continues to advance to t+1, t+2, and so on as time unfolds and new sets of inferences are made between the time boundaries. So the beliefs are parameterized by time. Inferences occur across those boundaries, and we have this evolving now. And then additionally, contradictory information, so say to arbitrary belief B, is easily determined by a mechanism with a specialized inference rule for, in the presence of a direct contradiction, namely or not B, then when this occurs in the knowledge base, after this point, the reasoner will assert a contradiction between this formula and its negation, and these will no longer continue to be used to derive further consequences. So we have quite a bit of computational savings over some other approaches to default reasoning, that these savings occur due to noticing contradictions only when they directly occur at the present now time step, and future contradictions can be dealt with when they may be noticed in the future, if they are noticed. So then, with some of these qualities and their special purpose inference rules in active logic, the prior work on active logic still had some limitations, namely the representational mechanisms for having beliefs that are mentioned, such as making a reference to formerly holding belief B, but that this no longer held, were not worked out in great detail. And we see that these representations can become quite complex, especially when the need arises to have an active logic-based agent making inferences about the attributed beliefs to other agents. So this, we use an approach for syntactic theory of quotation, but this on its own was insufficient, and quasi-quotation was also needed for more general reasoning, which now describe here. So as an example, we have a pretty standard rule expressing that a bird is going to be known to fly when we do not have our active logic agent in question knowing that, quote, not flies X, right? This bird does not fly. This is intended to express that default sentiment, but since we have our nested and quoted not flies within those quotation marks as a mention of this formula and not a use, ordinary quotes would obscure the fact that we're intending the three X's throughout this formula to mean the same thing, in this case at least. And so we use the device of quasi-quotation, which is indicated here with the backtick mark, to specially designate this variable to escape from quotation and have that intended meaning of 1x quantified throughout this formula. So this is a very simple example for that as an unquotation device. And in the more general case, when we may have arbitrary nesting of quotation and prepending of quasi-quotation backticks up to the level of enclosing quotation. This does get quite a bit more involved to have our syntactic unification. A general algorithm has been designed, implemented, and tested for a body of cases, but for limitations of space, this can be seen in the paper and in prior work as well. But making use of this developed quotation and quasi-quotation, we now then are able to represent in a satisfactory way in active logic evolving beliefs, evolving inference, and then make use of this device in case studies such as for hierarchical examples like with the mollusks, and additionally some other studies where we might have ontology categories that nest but do not fully overlap. That do not fully nest but merely overlap, as well as some other scenarios involving an agent reasoning in real time about what beliefs it may expect would be evolving for another counterpart agent. So for reasoning about the beliefs of others, now we turn to the problem of focus was the surprise birthday present problem, in which we assume that Alma, our agent instantiated with active logic, is interacting with fellow agents Bob and Carol, and specifically with Bob trying to plan a surprise present for Carol, and how can Alma and Bob together infer that they expect Carol will be surprised by it. So they must reason about what Carol does or doesn't know, and in particular scenarios such as if Carol does or does not overhear, then Alma might be able to notice that if Carol noticed their conversation, then Carol may not be surprised. And furthermore, Bob, who is nearby and can see Carol overhearing, also ought to infer that Carol will not be surprised. And lastly, then Alma representing her own beliefs about Bob's evolving beliefs about what Carol may come to believe as well. So although initial presentation of the problem may seem near triviality in some forms, this does become more involved when we consider Bob's and Carol's perspectives. So we solved forms of this problem using the active logic framework, especially in the case such as when Carol overhears, using both quotation and quasi-quotation to facilitate metacognition, and having the Alma agent making these models of the others. And we see similar considerations apply to other variations, such as if Carol is out of earshot. So then for purposes of limited space here, simply present rather than longer traces some results of this problem from Alma, the implemented active logic reasoner, when we begin with the scenario of Carol overhearing the plan from Alma and Bob. Ultimately, then the Alma agent leads to expect lack of surprise for Carol herself. And we see the formula numbers attached to these, which indicating that at an earlier point in time, Alma will first reason to her expectation that Carol will be unsurprised. And then as the temporal process of Alma's reasoning continues, arrive at Alma modeling Carol herself reaching the conclusion of failing to be surprised. Alma's model of Bob to conclude when Bob is considered to know the same facts of the birthday present problem that Alma does, that Bob will ultimately be unsurprised. And then the Alma's model of Bob modeling Carol's beliefs. So Alma expects Bob to make the same process as we see with Alma herself at a later point in time with the simulation of Bob. And so then any agent must account for these kinds of changes going on. And we can see that this is something that humans, as long as the depth of modeling other agents is not too great, tend to be able to intuitively do quite easily. And yet we produce this with active logic system making this kind of modeling. So then to conclude, AI here can reveal deep subtleties that, if not implemented, may have otherwise remained unsuspected. Specifically, subtleties of the time unfolding reasoning in active logic for both default reasoning with ontologies, as well as the modeling of other agents for the surprise birthday present problem, were found to be more involved in practice and revealed some of these subtleties when instantiating the system. And then more broadly, aspects of knowledge representation and reasoning that have been dealt with here, nested in time-varying defaults, as well as some select modeling of other agents' cognition, appear essential to common sense reasoning, human or not. And while the details of this may vary across the types of agents, abilities such as keeping track of changing past, present, anticipated future beliefs and inferences appear difficult to circumvent, at least in scenarios that are not significantly constrained. So thank you, and I welcome any questions.
Okay, thank you, Matt. We have plenty of time for questions, and I'd also like to remind the remote participants to put questions in Slack, and we'll present them live. So, Mike. Check the mic. Is it on? Not on?
Hello. Can you hear me?
Yes.
Okay.
Yes.
So, Matt, it's good work. I was a little confused, though. I saw and understood how when you say the step in line 2 was incorrect early on, that was an example of metacognition. But this example of the surprise birthday party seemed to be more theory of mind, your reason about other agents' beliefs. That's a clarifying question. Am I right, or was I missing something?
Yes, that would be correct. Mm-hmm.
A second clarifying question, you're using quotation, quasi-quotation. Yesterday in the active logic paper, they were using these bracket quotes. Did that map to one of those kinds of quotations, or was that different?
I unfortunately was not able to make it to that talk yesterday.
Is that author here? Nope. So my real question then is, there's this logical problem with normal logic. It's called referential transparency. It deals when you have aliases like Clark Kent and Superman. I forget the exact example, but does active logic handle that one? Are you familiar with what I'm talking about?
Yeah, to some degree. So that I think, right, that would be based on the mapping of that like symbol to intending, right, those two separate constants of Clark Kent and Superman, like in the world, mapping to the same person.
Example
I think
was that Superman can fly, and I forget the woman that knows Clark Kent, but she doesn't know, even though Clark Kent is Superman, she doesn't know that Clark Kent can fly. But
yeah. So in general, the approach that we have implemented with quotation and active logic would need to be extended a bit more to support that kind of example. For we could emulate something like that with additional knowledge indicating that we'd want to treat as equivalent those two constants in some cases. But the recent work on active logic with quotation had not focused much on that kind of example. Would remain a future extension to develop that further.
thank you.
Okay, any other live questions? Okay, so we do have a question from the Slack. The questioner is Lucian Galescu, and it's a little bit tough because he references an equation, so I'm going to have to read out the equation. We're going to see if we have a way to put up the equation visually. But he says, I'm not convinced that this quotation mechanism is necessary. Wouldn't a positive introspection axiom, and I'll just read the axiom, Bell of X and P, that's one predicate, equals Bell, and then open paren X comma Bell of XP. So he's putting the Bell of XP as the second argument to Bell with the first argument X. Is that clear? Does that make any sense? Okay.
I think I can also, I hope I can pause the share and view the equation directly.
Check it in the chat if you could.
Yes.
Slack rather.
So, okay, yes, I see this.
Okay. And the audience can look in the Slack to see the equation he's referring to.
So with regard to introspection, I would say that the implemented active logic system did have a form of positive introspection, not using Bell directly for the agent's own beliefs. In fact, if we, let's see, try resume the share, and the use of Bell for Carol and Bob, as we see in this example, is used for other agents, but we use positive introspection in lieu of Bell with respect to the ALMA agent's own beliefs. But so the introspection ability is present, but also the use of quotation, I think, can also be highlighted in some other examples of like more fine-grained ways to perform introspective checks in the knowledge base, such as like with, you know, say we have within several levels of quotation a variable X with 0, 1, or 2, you know, quasi-quotation marks unquoting that, we have different granularity in the ways we do the introspection to query the knowledge base. So if the, you know, benefits of that might be better shown in examples like that that were not as explicit in the slides.
Okay, so we have no more questions from Slack. One more call for live questions. Okay, if not, we'll proceed to the next paper.